Welcome, everyone. Today we're diving into the fascinating world of HF skywave propagation. Now, if you're new to amateur radio or just brushing up, you might be wondering, what exactly does HF skywave propagation mean? Don't worry, I've got you covered. Simply put, it's the way high-frequency radio waves bounce off the ionosphere to travel great distances. We're talking hundreds or even thousands of miles. Like, imagine chatting with someone halfway across the globe. Pretty cool, right? So why is this so important for amateur radio operators? Well, historically, HF skywave propagation has been a game changer. For example, it's played key roles during major events. Think World War II or disaster recovery efforts, giving people a vital way to connect when other communication lines were down. It's really the backbone of long-distance radio communication in a lot of cases. And here's the thing. This all works thanks to a layer in our atmosphere called the ionosphere. That's where the magic happens. This layer is made up of ionized particles that reflect radio signals back to Earth, instead of letting them just shoot off into space. Two key terms to know here are maximum usable frequency, or MUF, and lowest usable frequency, or LUF. The MUF tells us the highest frequency that can travel reliably over a given path, while the LUF is the lowest frequency that won't get lost in noise or absorbed by the atmosphere. To make sense of this, think about it like tuning into a car's FM radio. Ever notice how some stations disappear as you drive further away? That's because your signal gets weaker. But with HF signals and the ionosphere, you've got this bounce effect. So as long as you stick within your MUF and LUF, your signal can reach much farther. Now here's where HF becomes really interesting. Emergency situations. Say a hurricane hits, cutting off cell towers and internet access. HF radio can be the lifeline, allowing emergency teams to coordinate and communities to stay connected. And even with all the modern technology out there, HF has made a serious comeback lately, thanks to innovations like digital signal processing and devices that make it easier to operate than ever before. So, whether you're a seasoned ham enthusiast or just discovering this world, HF skywave propagation isn't just some technical term. It's a tool that's been saving lives and bringing people together for decades. And that's the kicker. It's not just history we're talking about. It's relevant right now, today, as we look at how technology and nature combine to keep us connected over long distances. Alright, so now that we've set the stage with the basics, let's dig into the nitty-gritty of ionospheric propagation, how it really works, and why it's so essential to HF communication. Picture this. You're sending out a radio signal, and somewhere up there in the ionosphere, solar activity starts to play its role. The sun's radiation ionizes the atmosphere, creating charged particles that interact with your signal, reflecting it back to Earth. This is where the magic of skywave propagation really hits home. Now, here's the twist. Solar activity isn't always your friend. Take solar flares, for example. These dramatic bursts of energy can flood the atmosphere with X-rays, leading to what's called a sudden ionospheric disturbance, or SID. Think of it like a traffic jam in the D layer of the ionosphere. Signals meant to bounce back can get absorbed, causing temporary blackouts on the HF bands. And let's not forget coronal mass ejections, CMEs, that can trigger geomagnetic storms, disrupting communication even further. I think I'd take a regular traffic jam over that any day, wouldn't you? And you know, history gives us some wild examples of these disruptions. Back in 1859, the infamous Carrington event, a monster solar storm, fried telegraph systems worldwide. I mean, operators reported sparks flying from their equipment. Imagine a modern-day event like that. Our communication systems wouldn't stand a chance. That's why understanding these dynamics isn't just a nerdy fascination. It's like seriously practical for anyone working with radio. All right, let's zoom out a bit. There are essentially three main methods radio waves use to propagate: line of sight, ground wave, and skywave. Line of sight is what it sounds like. It's a straight shot between antennas, but limited to short ranges. Ground wave? It hugs the Earth's surface, which is great for low frequencies, but distance? Not so much. Skywave, though? That's the jackpot. By bouncing off the ionosphere, those HF signals can travel thousands of miles, connecting communities across continents. No cell towers, no satellites, Just you, your gear, and the ionosphere. And here's the thing that truly sets Skywave apart: its resilience and versatility. For one, it thrives in situations where infrastructure fails, but it's also unique in how it's influenced by time of day, seasons, or even solar cycles. It's this ever-changing living system. Honestly, it's fascinating, and it gives us, as operators, this constantly shifting puzzle to solve. Like, can you think of another communication method this dynamic? It keeps us on our toes, that's for sure. Let's get practical here. What tools can help you navigate these changing conditions? Two of my favorites are DX view maps and real-time propagation reports. Imagine pulling up a map that shows, in real time, which bands are open and where your signal is likely to go. With data from sources like ionosphere and digital modes like WSPRnet, you can plan your contacts more strategically, figuring out the best times and frequencies for your setup. Trust me, once you start using these tools, it's a total game changer for improving your reach and efficiency. So whether you're aiming for a quick QSO with a nearby ham or trying to reach a faraway station across the globe, understanding these propagation methods, alongside the tools at your disposal, makes all the difference. And don't worry, there's plenty more to explore. In our next segment, we're diving into how to track digital modes like FT8 and WSPR to better understand propagation dynamics and optimize your communication outcomes. Stay tuned for that. So here we are, wrapping up this deep dive into HF Skywave propagation. Let's shift gears and talk tools, tips, and strategies that can level up your amateur radio game. If you've ever felt lost wondering how to make better connections or optimize your setup, this is where things start coming together. First up, let's talk digital modes like FT8 and WSPR. These are absolute game changers. FT8 is fantastic for low-power contacts when conditions aren't ideal, and WSPR is like a propagation detective. It lets you see how your signal travels in real time. Imagine sending out a whisper of a signal and then tracking exactly where it reaches on the globe, even under poor conditions. It's kind of magical, isn't it? Plus, tools like PSK Reporter and WSPRnet have made this process easier than ever, allowing you to experiment, fine-tune your setup, and get immediate feedback on what's working or not. Now, let me introduce you to something else that can elevate your awareness: global beacons. These are installations all over the world that transmit standardized signals. By tuning into them, you can quickly gauge band conditions and pinpoint which frequencies are active, all without needing a ton of equipment. It's like having a weather forecast system, but for propagation. And because the learning never really stops, I highly recommend diving into a glossary of terms and some curated resources. Knowing the difference between terms like MUF and LUF, or understanding the phases of a solar cycle, doesn't just make you sound knowledgeable. It sets you up to be a more effective operator. Start with accessible online references or trusted tutorials for amateur radio. Trust me, you'll find yourself picking up something new every time. The bottom line? Amateur radio isn't just about the gear or even finding that perfect contact. It's about tapping into this incredible mix of science, technology, and exploration. The tools we've talked about today, digital modes, real-time data, global beacons, they're here to help you get the most out of the frequencies. It's like solving a different puzzle every time you fire up your rig. And that, to me, is what makes this hobby endlessly rewarding. And on that note, folks, that's all I've got for today. Hopefully you're leaving with some inspiration to experiment and build your skills. The ionosphere is waiting, and there's always more to learn and discover.